Hi, this is Jason Baker, and welcome back to our lecture. I've talked a bit about the Swarm orchestration platform, and let's spend a little bit of time working with the platform so you can kind of get an idea of how you can launch and create and scale services. So in order to do that, you need to launch a Docker Swarm cluster. And I've already gone ahead and created a Swarm stack that you can use to launch a cluster using CloudFormation. This this stack will create a set of manager nodes and a set of worker nodes. It will automatically initialize a Swarm cluster, and it will then add all of the manager and worker nodes to the cluster. Now, this stack takes a little bit of time to complete. It might take, 15 minutes or so. So if you want to follow along with this hands-on part of the lecture, then you might want to pause the video here and go launch the stack. And once the stack is created, then you can go and to the initiator node. So if you look in EC2, you'll see your different Swarm node instances running. One of them is labeled the Swarm initiator. That's the Swarm manager node, the first Swarm manager node that was used to initiate the creation of the Swarm cluster. And if you just simply SSH to the IP address of that initiator node and log in as the Ubuntu user using your key pair, then you'll be able to get shell access to that manager node. And you'll need to get shell access to the manager node in order to run these different Docker Swarm commands. I have a diagram here which is describing the the uh, the Swarm cluster architecture that's created by this CloudFormation stack. We have uh, we have cluster resources running in a VPC, and those resources are partitioned across multiple availability zones. Each availability zone has both a public subnet and a private subnet. Most of the Swarm cluster nodes are running within the private subnets in each one of the AZs. And each of those Swarm nodes is also running as part of an auto-scaling group. And then the Swarm nodes are proxying connections out to the internet through NAT gateways, since most of these nodes are running within within private subnets. The initiator node is running within a public subnet, and that's the only node that you can directly SSH into from the internet. So this is kind of a, a, a summary of how that uh, Docker Swarm cluster is has been created. Okay, so let's start working with the cluster. I've already gone ahead and logged into one of the cluster nodes, and I'll increase the size of my text here so you can see it a little better. Um, so we're going to run a series of commands here, and when we're running these commands, we are going to be communicating with the Docker Swarm service. The first command I'm gonna run is a command to deploy a new service into the cluster. And I can do that using the Docker service command. So I'm gonna create a new service, Docker service. I'm gonna create a service with one replica. So say a single replica. The name of the service is just going to be, we're going to call it the Hello World service. And it's going to be running the Alpine image. So the Alpine image, because we didn't prefix it with any sort of namespace, that means that this is a utility image that Docker Swarm will download automatically from from Docker Hub. Docker Swarm needs to be able to download services or download Docker containers from some sort of repository. So either it's going to use Docker Hub or it's going to use a private repository such as AWS ECR. Um, and then finally, uh, we're going to specify that the containers created by this service are going to run a command, and that command is going to be to ping the docker.com website. So we'll go ahead and create that service, and you can see that Docker Swarm has created a single task or a single replica, and it's verified that the service is running. So now if I do Docker service ls, which lists the services running within the Docker Swarm cluster, you can see that I have a single service called the Hello World service. It's got a single replica, and it's running the latest Alpine image. And each service also has a service ID. I can get some more information about that service if I run the Docker service command and use the inspect argument. I want to inspect the Hello World service, and this will return back typically this will return back a JSON document, which then you can programmatically parse. But I provided this dash dash pretty argument, which provides us with sort of a more human readable output from this command. So now we can see that we're running a service called Hello World. It's got a single replica, meaning we have a single container that's running as part of this service. And it tells us the actual image that it's using. That image has a SHA value. It tells us any sort of command arguments that were provided for that image. And now you might be asking the question, where exactly is that container running within the cluster? Because this cluster has at least 5 nodes. So we can run the Docker service ps command and then hello world. PS stands for process. So we want to get some more information about the Hello World service and the processes that are running as part of it. So we run that command, and it tells us that the service is running a single replica, and it'll list out each of the tasks or each of the containers as part of the service. So we have a hello world .1, meaning that it's the first container or the first task, and that's running on this particular node. If we do a Docker node ls command, you can get a list of all the different nodes in the cluster. So here's that particular node within the cluster. So that's where this particular task is actually running within the cluster. Now, we only have one task or one container running as part of the Hello World service. Let's say we want to go ahead and scale that. We can do that by using the Docker service scale command, and we can scale the Hello World service, and we can tell it that we want it to run 5 tasks. And Docker Swarm will go ahead and start up those tasks. Now, if I do a Docker service ps hello world, then you'll see that now we have 5 tasks running, hello world.1 through hello world.5. And you can see that these tasks are running on multiple nodes. This environment actually has, I think by default, 3 manager nodes and 2 worker nodes. So we would expect to see these tasks sort of evenly distributed across the 2 worker nodes. Okay, so um, if I do, if I run a Docker PS command, right now I'm on a manager node. So you can see if I run a Docker PS command, you see that there's no hello world container running on this particular host. So this cluster is set up so that all of the containers are running and all the services that we create, all the containers are running on worker nodes. They're not going to start up and run on the manager nodes. Okay, so let's say we don't want that service to be running anymore in our cluster. We can say Docker service RM, which stands for remove, and then give it our service name, remove hello world. And then if I do a Docker service ls, you'll see that now that service is gone. It's no longer running within our cluster. Okay, well, let's do something a little bit more sophisticated. We're going to go ahead and create a database service using the Redis database server. And we're gonna create that database service using a specific Redis version, a container version, the 3.0.6 version. And then we're gonna upgrade that Redis service to 3.0.7. So let's go ahead and do that. We'll say Docker service create. We want to create a service with 3 replicas. And the name of the service is going to be the Redis service. When we update that service, we're going to update it. We're going to update it using an update delay of 15 seconds, meaning that we're not going to update all of our Redis tasks immediately. We want to update those tasks one by one, and we want to introduce a 15-second delay between the updating of our individual Redis containers. And then we're going to specify the image that we should use for the containers in the Redis service, which is going to be the Redis 3.0.6 version. So that's the 3.0.6 tag. We'll go ahead and launch that. And now the Docker Swarm orchestrator has downloaded those container images and it's deployed those services. Now if we do Docker service ps Redis to look at the service processes, you can see that I've got 3 different services or 3 different tasks running on 2 different nodes in the cluster. And they're all running Redis 3.0.6. So let's go ahead and update that service. We can do that by updating the service definition. So right now, we've specified that we want this service to use this particular image. We can go ahead and change that image for the service, and then Docker Swarm will automatically then perform a rolling upgrade of each of our containers within that service so that each container is using the new version. I do a Docker service update, specify the image, which is Redis 3.0.7, and I tell it I want to update the Redis service. And so now the Swarm cluster is going to progressively update each one of these tasks. And you can see that it's updated the first one, it's waiting 15 seconds. Now it's updated the second one, and it's going to wait another 15 seconds, and then it will update the third one. Okay, now it's updated the third one. And if I do a Docker service PS Redis, you'll see that we have 3 Redis tasks. They're each running, and they're running at version 3.0.7. Now, because we've performed an update, we can still see the old containers that were running 3.0.6, but those containers have been shut down. If we wanted to, we could roll back to those previous container versions, and then the Docker Swarm Orchestrator would shut down these existing containers that are running and active, and it would restart the containers that were shut down that are using version 3.0.6. If I do a Docker service inspect pretty on Redis, then you can see that the service is now using the new Redis 3.0.7 container image. Now, let's go ahead and scale the services that are running. We have 3 Redis containers. Let's go ahead and increase that. So we want to scale that up to 5. So we've scaled it up to 5 containers. And now we do a Docker service PS Redis. And when I do that, you can now see that there are 5 Redis containers, and the new Redis containers that were started up are using the 3.0.7 version. So remember, we updated the service definition, and we said that our desired state is that the Redis service is running the 3.0.7 image. So any new tasks or containers that are launched by the orchestrator are going to use the desired image that we've specified for that service. Now, sometimes I mentioned that we need to be able to drain a node in our cluster and remove the services that are running on that node. Let's go ahead and do that. So I'm going to pick one of these nodes. Let's say this 141 node here, and I'm going to copy that node ID, and I'm going to say Docker node update. I'm going to change the availability setting of that node and change it into drain mode. So I'm going to drain that particular node. Now, if I do a Docker service PS Redis, you'll see that here's our 141 node, and Redis has been shut down on that node. So all of our Redis services, if you take a look at them here, all of our Redis services that are running are now running on this .85 node. So they're all running on the same node now. Let's go ahead and change the availability of that node back to active. So we've updated that node and changed it back to active. If I do another Docker service PS, what you'll notice is that nothing has changed. So even though I've added that .141 node back into the cluster and made it available, the Swarm scheduler is not going to automatically move containers back to that node. If if I want to move containers back, then I need to do a Docker service update and force an update of the Redis service. And that will essentially cause the orchestrator to rebalance the services running inside or rebalance the containers so that they're going to be running on multiple nodes in the cluster. Because they set a 15-second update delay, this is going to take, probably a minute and a half or 2 minutes to update these 5 running services. So we've updated 4 of the services, and now we're just waiting for that last service to update. If I do a Docker service PS Redis, and what we'll see now that, now some of our tasks are running on the .141 node again. So they're more evenly distributed across our cluster nodes. Okay, so we're done working with this service. Let's go ahead and remove the Redis service. I do a Docker service ls. You'll see that the Redis service is now gone. Well, so far we've been sort of launching these services into the cluster, but we're not really interacting with the services. So let's do something a little bit more interesting, and let's actually create sort of like a simple application that we can interact with. What I'm going to do is I'm going to start by creating an overlay network. And remember, an overlay network is this layer 2 network which spans across all of our cluster nodes, and we can then attach services to the overlay network. There's a default overlay network that's automatically created for you. So if you don't specify the network that a service should attach to, it will attach to this default network. But in this case, we're going to specifically define an overlay network, and then we're going to attach multiple services to it. And when those services are attached to the same overlay network, they can then communicate with one another. Then finally, we will publish a port for one of the services so that we can access the service remotely from the internet. So we'll go ahead and start by creating a Docker network. So we'll say Docker network create. We're going to use the overlay driver, and we're going to specify a subnet of 10.2.0.0/24, and we're going to call it our pets overlay network. So if I do Docker network ls, you can see that now there's a pets overlay network in place. Now we're going to add a database service, and that database service is going to use Consul. Remember, Consul is a service discovery platform. It can also serve as a key value database service. So we'll go ahead and create a new service called Docker. So we'll use Docker service create. We're going to attach this service to the pets overlay network. We're going to name the service the DB service, and it's going to use the latest Consul image. Now, I didn't specify how many replicas of this database service I want to use. And in this case, I just, it'll default to 1. I'm just running one replica of this database service. So if we do Docker service PS DB, then you can see that here's our database service, one replica or one task, and it's running on the .141 node. Now I'm going to run a second service, and I'm going to create that service. It's going to be on the same network, which is important because I want these two services to be able to communicate with one another. I want it to run two replicas of this service, so two containers, and I'm going to map. So I'm going to publish the port on these containers. I want to map port 80 on the host to port 5000 within the container. And I also want to define some environment variables that will exist. In this case, the environment variable is defining the database endpoint. So I'm specifying that the database endpoint is simply DB, which is the name of the database service. Because remember, when we create a service within a Docker Swarm cluster, Docker Swarm will automatically create DNS records for us, which map the containers for that service to the service name. So if I want to reference, if I want this web service, this web application to be able to communicate with the database service that I created earlier, all I need to do is give it the database service name as an endpoint address. So the name of this service is the web service, and I'm going to use an image that's published on Docker Hub that somebody created. And it will go ahead and download and start those images. Services have started. Do Docker service PS web. And you can see that we have our two tasks or two containers of our web service now running. Now, these services are being published to the Swarm cluster, meaning that we're mapping port 80 and our Swarm cluster nodes are now listening on port 80. In our cluster environment, in our Swarm stack that we launched using CloudFormation, we're using an elastic load balancer to distribute requests into that environment. So if I go and if I look at my load balancers, I will see that there is a Swarm ELB that's defined. And if I look at the instances, you'll see that these are pointed at my two Swarm worker nodes, and each of these instances is reporting that it's in service. So this is using a classic elastic load balancer. It's not using the application load balancer that we've used previously in the course. Now, if I want to access this web application now that's running within the cluster, then all I need to do is go to this ELB endpoint address. So I'll in a separate browser tab, I'll browse to that endpoint address, and you see it pulls up a web application for me, which is called Docker Pets as a Service. And I can enter in a pet name. Let's say we call our pet Spot, and our pet is a dog. So I click dogs, and it comes up with a funny dog animation. And then you can see it says one pets served. So it's kind of storing some state information in the console database. I can vote again, and I can vote for my my pet whale, and it gives me another animation that tells me now 2 pets have been served. I click on serve another pet, and you can see it'll just keep pulling up different sort of animations, and it will increment the number of pets that are served by the application. So very, very simple application. And the point of this is just to show you how we can deploy multiple services into a swarm cluster, and um, we can connect those services together over an overlay network. We can use the service name as an endpoint address to kind of wire up the applications running in one container to communicate with applications in another container. And then we can publish a service so that it is accessible from outside of the cluster. In this case, we're using the Elastic Load Balancer to as a single DNS endpoint, and that will then redirect requests and distribute those requests across multiple cluster nodes. So this service is actually pretty resilient other than the database. The database is only running a single node. In a production environment, we'd probably run, 3 console servers so that we can store that information uh, across multiple servers in a more resilient manner. And so the Swarm cluster allows us to orchestrate all these containers. We don't have to worry about actually launching the individual containers. We just define services, and then we let Docker Swarm figure out where to run the containers within the cluster, figure out how to update those containers, how to scale the containers. It provides us with a service discovery mechanism to wire containers together, and so on. And typically, we're not actually entering in these commands manually, like you've been seeing me do as part of this hands-on demonstration. Like everything else, there's a way to build these services using code. So in the case of Docker, a Docker Swarm cluster, we can use a Docker Compose file to specify the service configuration, and then we can launch what's called a Swarm stack, which is a set of services. So we can define a Swarm stack and then launch that Swarm stack, and Docker Swarm will then automatically deploy all the services for us, and set up our application and publish the ports and set up the ingress routing network, and so on. So it's a great service. I've used it pretty extensively over the past year or so because of my company has deployed a number of applications using this technology. And I think one of the benefits of Docker Swarm is its simplicity. It's a very easy uh, Docker container orchestration platform to deploy and manage. It's not as sophisticated as something like Kubernetes. So, Docker Swarm probably provides like 80% of the functionality of Kubernetes, um, but it's significantly easier to use than Kubernetes. If you need some of the more advanced features of Kubernetes, then that's the solution you need to use. But if your needs are less complex and fairly straightforward, then Docker Swarm is a very good solution to use.